we're going to evaluate the limit using L'Hopital's rule as x approaches 1 of the square root of x minus the cube root of x all over the denominator of x minus 1. Before we use L'Hopital's rule, let's kind of get our footing and see, well, why do we need it in the first place, right? What happens if we just evaluate this limit as x approaches 1? To do that, we just plug in 1. So we'd be looking at the square root of 1 minus the cube root of 1 all over 1 minus 1. It's going to give us 1 minus 1 over 1 minus 1, 0 over 0. Undefined. All right, now it's time to use L'Hopital's rule. L'Hopital's rule gives us that the limit as x approaches whatever number is equivalent to the derivative of the numerator divided by the derivative of the denominator, right? So we keep this limit, so the limit as x approaches 1, L'Hopital's rule kicks in here. The derivative with respect to x of root x minus cube root of x all over derivative of the denominator. In terms of taking derivatives of roots, I turn this from a root to the exponent as a fraction and rock and roll from there. Turning the exponent into a fraction for me personally is just how I find it easier to make sure I'm doing this correctly. So really, I'm thinking of this problem as the limit as x approaches 1, the derivative of the numerator. The square root of x is equivalent to x to the 1/2, right? This denominator, reminder, is whatever the root is. So as you can guess, or as you know, this is going to be minus the cube root of x is really minus x to the 1 over 3, right? Because that's what's on the outside. All over the derivative with respect to x, the denominator is just going to stay the same. All right, well, when we do this, limit as x approaches 1, let's take these derivatives. The derivative of x to the 1/2, we're going to drop that exponent down, leave x, and then 1/2 minus 1, or 1/2 minus 2 over 2, right, is equal to negative 1/2. So negative 1/2 up here. Same thing with this x to the 1/3 over here. We're going to drop that 1/3 in front, leave the x, 1/3 minus 1, or 3 over 3 is equal to negative 2/3. So this is negative 2/3. All over the derivative of x is just going to be 1. So that's 1 minus nothing, right? Because the derivative of negative 1 is 0. So our denominator is just going to stick around as 1. Let's simplify from here. Let's say this is equal. Anything over 1 is just itself. So this denominator kind of is just going to go away in the next step. Let's break each of these down. So we have this right here. When we look at 1 over 2 times x to the negative 1/2, what we're really dealing with is 1 over 2, right, times this negative tells us that the x to the 1/2 needs to be in the denominator, and then this just turns into the root again, right? So 2 times root of x is our denominator. Popping that over here. Okay, and then this one. 1 over 3 times x to the negative 2 over 3, right? Same thing. We have 1 over 3. This negative 2/3 tells us that x to the 2/3 should really be in the denominator. And then let's turn this into the proper radical. When you have a fraction as an exponent, the numerator stays with the variable and the denominator turns into whatever the root is. So this is the same. And that's how I'm going to write this over here. Let's evaluate this limit. Plugging in 1 wherever we see x. So 1 over 2 times root of 1, since we're plugging in 1 for x, minus 1 over 3 times the cube root of 1 squared. Well, that's just going to equal 1 over 2 times, square root of 1 is 1, so 2 times 1 is just 2, minus 1 over 3 times, this is 1 times 3. We want the least common denominator of 2 and 3 is 6. So 1/2 is really 3/6, and 1/3 is 2/6. 3 minus 2 is 1 over that common denominator of 6. So this is our answer. Okay, if you guys have any questions on how to do this problem, if you could use some help with your fractions, if you can use some help with your derivatives, if you could use some help with your roots and those fraction exponents, please leave a comment. I'll be doing my best to make more videos of whatever it is you guys need help with. If you found this video helpful, please hit the like button, send it to your friends. If they need help, they might get something out of this video as well. And subscribe for more if you are looking for more helpful video content like this on calculus or math. Thanks!